Shalom class, my name is Innocent Mapanda. I hope I find you well. In today's lesson, we'd like to touch on first order differential equations. Right, so I have extracted question number 13 from paper 1 November 2012 ZIMSEC or Zimbabwe School Examination Council. Right, it reads, a colony of ants brings food to its hive at a constant rate of 500 grams per day. It consumes the food in the hive at a rate of half x grams per day, where x is the amount of food present after time t days. So x is representing the amount of food, right? So I want you to notice something. The first part of the question is indicating that a colony of ants are bringing food to its hive. Bringing food to the hive, it means that we have got a positive differential coefficient. Right, so what you need to do, you have to write dx. Dx, it means the rate of increase of food. Right, then you divide it by dt. Right, so dx over dt, it means the rate of increase of food, which is x, with respect to time, where time is being denoted by the small letter t. Right, so I'm going to write dx over dt as a positive differential coefficient. Why? Because the colony of ants brings food to, brings food to it. It is a sign that the food is increasing, right? But if the food was decreasing, I was going to put a negative sign before dx over dt, right? So it brings food to its hive at a constant rate of 500 grams per day. So constant, it means that there is no variation there. Then I'm going to put equal sign, right? Then you write 500. So the rate of increase of food with respect to time at a constant rate of 500 grams. You write dx over dt is equals to 500. Let us move on to the second sentence. It consumes the food in the hive at a rate of half x grams per day. So the consumption, it means that the food which was brought into is now being reduced through the consumption, right? So I'm going to reduce 500 by half x. So half x is representing the consumption of food, right? So let us move on to the first equation. Taking x and t as continuous variables, write down a differential equation satisfied by x and t to show the rate at which food is increasing in the hive. 2 marks. So dx over dt is equals to 500 minus half x. This is the differential equation. You get yourself 2 marks. Right, we now move on to part 2 of the question. Solve the differential equation leaving x in terms of t. Given that t is equals to 0, x is equals to 400. So we are given that t is equals to 0 when x is equals to 400 grams. So this complete set will help us to find what we call a particular solution. But before you find the particular solution, you first of all find the general solution. Right. So for it to be possible to solve this differential equation, we have to combine 500 with minus half x to make it a single fraction. Right. So I'm going to write 500 as 500 over 1 minus half x, right? So to make it a single fraction, you identify the LCM of the denominators, which is 2, right? 1 into 2, you get 2 times 500, it gives you 1000. 2 into 2, it gives you 1 times x, you get x. So we have managed to combine 500 and minus half x, right? So the idea when solving differential equation is to collect same variables on the same side, right? So Remember, this can be achieved through the process of cross multiplication, right? So I'm going to cross multiply. So if I cross multiply dx times 2, you get 2 dx. Then 1000 minus x times dt, you get 1000 minus x dt, right? But still, we do not want to see an element of x attached to a differential coefficient dt. So we need to move each and every element of x to the same side. So I need to divide both sides by 1000 minus x, right? So dividing both sides by 1000 minus x, you get 2 over 1000 minus x dx. Then you'll be left out with dt on the right side, right? So we have managed to collect similar variables on the same side. So in order to then solve the dE, you have to put integral signs both sides, right? So remember, when integrating inverse functions, take for example, you want to integrate 2 over 3x minus 4 dx. You want to integrate this inverse function. The first thing is to write the numerator, which is 2, right? After writing the numerator, which is 2, you have to divide 2 by the derivative of the denominator. So the derivative of 3x is 3. The derivative of minus 4, since minus 4 is a constant term, you get 0. Then you put your ln, then you write the denominator under modulus. So this is how you integrate an inverse function. So we would like to do the same on our left side, right? So integral of 2 over 1000 minus x. The first thing is to write 2. Derivative of 1000. 1000 is a constant term. So derivative of 1000 is 0. Right, derivative of minus x. Remember, minus x is good as minus 1x. So derivative of minus 1x, you get minus 1. Then you put your ln 1000 minus x like this. Then you put your equal sign, right? So integral of dt, it means there is a silent 1 in between the integral sign and the differential coefficient dt, right? So integral of 1, you get t. Then you have to put plus c. So this is the first thing to do, right? So let us simplify on our left side, right? You are going to come out with minus 2 ln 1000 minus x is equals to t plus c, right? So remember, the question is requiring you to make x the subject of the formula, right? So to make x the subject of the formula, let me remove the negative 2. Let me divide each and every term both sides by minus 2. So I'm going to divide this by minus 2, this by minus 2, and this by minus 2. I hope you are listening, class. So you'll be left out with the ln 1000 minus x on the left side. Then you'll be left out with t divided by 2 is good as minus half t. Minus half t. Then c divided by minus 2 is a constant term. So a constant term can be replaced by another constant term. So c divided by minus 2, we can just represent c over minus 2 by another constant term, which is a. I hope you are listening, class. Right. So after that, we need to raise both sides by exponential. So I'm going to raise both sides by the exponential like this. I have raised here and I have raised here by the exponential, right? So if you followed the integration episode 1, I told you that if you come across with the e to the power of ln 9, it means that your answer is 9. So if you raise exponential by a Napierian log, you come out with the number in front of the log, which is 9. I hope you are listening, right? So what I'm trying to say is, e to the power of ln 1000 minus x, it means that you'll be left out with 1000 minus x on your left side, right? Then you make use of the indices aspect, right? So it means that e to the power of minus half t plus a can be likened to e to the power of minus half t dot product e to the power of a. It means that if you multiply the two, you then add the powers. So this is good as this in terms of product using the laws of indices. Right, so we now have 1000 minus x is equals to e to the power of minus half t times e to the power of a. Right, so be flexible when solving a DE. Remember, e to the power of a is also a constant term. Is also a constant term. It can also be replaced by another constant term. So we can replace e to the power of a with a constant term like b. Right. So I will rewrite the equation as 1000 minus x is equals to e to the power of minus half t dot product. So e to the power of a, I have replaced it by another constant term which is b. Right. So remember, the equation is requiring you to make x the subject of the formula. Right. So it means that I'm going to move minus x to my right side. Then the product of e to the power of minus half t and b on our left side. So we now have 1000 minus b e to the power of minus half t, moving this to our left side. Then minus a to the right side, minus x to the right side, you get plus x, like this. So this is what you call a general solution, right? But we need a particular solution. That's why the question gave you a complete set that t is equal to 0 when x is equal to 400 grams, right? So this complete set will then help you to find the b, the constant b, right? So we have to substitute 0 on t and 400 on x so that we can calculate the constant b, right? So 1000 minus b e to the power. So if I put 0 on minus half t, it means the whole power becomes 0, right? Then on my left side, I'm going to write 400. So you'll be left with 1000 minus b. Remember, e to the power of 0 is good as 1 using the laws of indices. Then you equate it to 4 to 400, right? So 1000 is a like term with 400. So I'm going to move 400 on my left side. Then you have to move b on the right side to become a positive b. It gives you 600 is equals to b. So I'm going to substitute 600 on my general solution to come with a particular solution. So we now have 1000 minus 600 e to the power of half t is equals to x. We have managed to make x the subject of the formula. So this is our final answer. I hope you are enjoying the lesson class. Let us move on to the next segment. Right, we now move on to part 3 of the question. Find correct to 3 significant figures the time at which the amount of food in the hive is 980 grams. So we are given x. Remember, x is representing the amount of food. Right, so we are given x as 980 grams. So we want to find the value of t when x is equal to 980. Right, so it means that I'm going to write 1000 minus 600 e to the power of minus half x can be written as minus 0.5, minus half t can be written as minus 0.5 t. Right, then you put 980 on your right side like this. So we would like to collect like terms. So 1000 is a like term with 980. So I'm going to move 980 to my left side. It becomes a negative number. Right. Then minus 600 e to the power of minus 0.5t. I'm going to move it on my right side. It becomes a positive answer. Right. So 1000 minus 980, you get 20. Is equals to 600 e to the power of minus 0.5t. Right. So the idea is to make t the subject of the formula. So I then need to divide both sides by 600. Divide both sides by 600. So 600 and 600, they cancel out each other. You'll be left with e to the power of minus 0.5t. Then 0 and 0, they cancel out each other. 2 into 2, 1. And 2 into 6, it gives you 30. Right. So to make or to solve this exponential equation, you take ln both sides or log both sides. So let me take ln both sides. Ln 1 over 30 is equals to ln e to the power of minus 0.5t like this. Right. So you write ln 1 over 30. Right. Using power rule. Power rule says that if you have got ln p to the power of a, you can bring down the power and rewrite it as a ln p using the power rule of logs, right? So we can bring down negative 0.5 to the power like this. Then you write ln e, right? But you need also to note that ln e is good as 1. Why? Because ln represents an Aperian log, which is log to base e. So ln e is good as log to base e and e. So if the base and the number in front of the log are similar, it means that your answer is 1. Right. So ln 1 over 30 is equals to negative 0.5t, since ln e is good as 1. I hope you are listening, class. Right. So to find t, I then need to divide both sides by negative 0.5. So ln 1 over 30 divided by negative 0.5 is equals to t. Right. So I'm going to punch this in my calculator. Right. Ln 1 divided by 30. Right. Divided by negative 0.5. You get 6.80, 6.8023, but the question is requiring you to give your answer to 3 significant figures. So 1, 2, 3. 2 is a number which is less than 5, so it means I'm going to be left out with 6.80 is equals to t. Right, so my final answer is 6.80 days, since our time is in days. So this is how you solve the value of t when x is equals to 980. I hope you are listening, class. So we are now moving on to the last part of the question. Stay tuned. Welcome back to part 4 of the question. It reads, find the maximum amount of food which the hive can have. Explain why this amount of food cannot be exceeded. Right. So the first thing to do in order to identify the maximum amount of food, you can rewrite this as 1000 minus 600 all over to e to the power of half t is equals to x. Remember, using the laws of indices, x to the power of minus a is good as 1 over x to the power of a. Right, so minus half t, e to the power of minus half t can be written as 1 over e to the power of minus t. Right, so if you multiply it by minus half t, if you multiply it by 600, you get 1000 minus 600 divided by e to the power of half t. Right, so there is what we call the limit theory. Right, I want you to notice something. Right, as t approaches infinity, you will notice that 600 over e to the power of half t is going to approach 0. Why? Because if t becomes large, if days increase, you will find out that this denominator e to the power of half t is going to become too large, whilst the numerator is going to remain fixed at 600. Right? So having a large denominator whilst the numerator is constant, it means that as time increases, the whole fraction tends to approach 0. Right? So it means that you'll be left with 1000 minus 0, as this 600 divided by e to the power of half t approaches 0. Right? So it means that the maximum amount of food that can be found in the hive is 1000, and we cannot exceed this. Why? Because as t approaches infinity, you will find out that the fraction in front of 1000, which is negative 600 over e to the power of half t, would then approach 0. Why? The denominator becomes too large, whilst the numerator is fixed at 600. So your final answer is 1000. So this brings to the end of our first episode, first order differential equation. Let us meet again in the second episode. My name is Innocent Mapanda. I hope you enjoyed today's lesson. Be blessed. Till we meet again. Shalom.